Okay, so now I'm going to show you how to do what's called the molar mass. How do you calculate this? How do you use it in a problem and so forth? So we're going to start with how in the world we calculate this. So in your notes here for part 4, what I have for you, molar mass I will abbreviate throughout the year as MM. AAM is that average atomic mass that we've been talking about before and we've been working on calculating. But we are going to be using what we're given on the periodic table and using that in the value or the units of grams per mole. So it says in your notes again, this means that the mass of 1 mole of any atom of the element has that many grams for each mole. So for example, carbon has 12 grams for every mole. Use that in the last part here for a practice problem. Magnesium would have 24 grams for every mole and so forth. So we would say that the molar mass of carbon is 12 grams per mole and the molar mass of magnesium is 24 grams per mole. And this means we can calculate how many grams of the atom we have if we know the moles and vice versa. So whenever we do this, we're going to shoot to round to the hundredths place. So if you look here, the mass in grams of 1 mole of a substance, molar mass of N is 14.1 grams per mole. That is what it has in your notes as an example, but we're going to look at a couple others and how we would figure these out. So if we need to calculate the molar mass of the following, and I give you sulfur and potassium, we need to figure out what they are. Then we're going to go ahead and try a conversion problem with them. So if we look at sulfur and potassium, so in the periodic table, which hopefully you have one in front of you, you will need this here. So I'm just going to grab a highlighter real quick. All right, so I've got a highlighter here. What you're looking for is that carbon number is right underneath here. So right there, it has an atomic number of 6 up top. That's not the one we're looking at. We're looking at that other number on the bottom here. Okay, so that's where you'll find that carbon is 12 grams per mole. And if we look, and we're looking for sulfur in this case, so sulfur's down here. If you read this number right here, what that number is going to tell you is it's about 32.06, depending on which periodic table you're looking at. And then potassium, same thing. We want to read this number right here. Okay, so just to write those down so you have them in your notes here, some practice. So sulfur, we are looking at 32.06 grams per mole. Okay, and then if we look at that number, like I said, for potassium, so potassium, if we break that out here, so you've got potassium. If you look where that is again, I highlighted it in the picture over here. So that should be 39.10 grams per mole. Okay. All right, so just getting familiar with reading those, and then we're going to be working kind of in a minute how we would calculate a full compound. So if we look at the number of copper atoms in a 63.55 gram sample of copper, you're going to kind of see how we can start using this stuff as we move along here. So we're going to use this in a practice problem. I'm just going to do it down here. So I'm, once again, going to always write down what I'm given first in the problem. So that's at 63.55 grams of copper. Since we have grams up here, we need grams down here. And I'm trying to ultimately get to moles and then atoms. So I'm going to put 1 mole here. Now, what number goes here, we need to find from the periodic table. So if I look up to copper, which is right here, and I read this number right here, that's the number I'm going to need. So that number there is 63.55. So it's going to be that same number that we started with. Okay. And then that last step should be pretty familiar. We're going from 1 mole to the 6.02 times 10 to the 23rd. And we are going to atoms here. So you can double check. So this will cancel with this. Moles will cancel, meaning we're left with atoms, which is good. That's what we want. So if you go ahead and multiply that out, because these end up being the same number, they're going to cancel. So our answer is going to be the Avogadro's number here. So 6.02 times 10 to the 23rd atoms. Okay? All right, now we're going to have to be able to do something a little bit more complex with these and find the molar mass of compounds. So in order to find the molar mass of a compound, you're going to add up what you have together. So that example that's in your notes there, we have H2O. You're going to take 2 times the value for hydrogen, add it to the number of oxygen. So if we look up here again, so hydrogen is going to be over here. It's about 1. It's 1.01. So if we go with that, we're going to take 1.01 times 2 plus the number for oxygen up here. You're looking at 15.999, which is going to round up to 16, okay? We go ahead and multiply this out. You're looking at a value of 18.02 grams per mole for water. Now, the only other thing that gets a little tricky with these, so if we look at the next example in your notes, the barium nitrate. So keep in mind that these numbers are going to distribute. We talked about this earlier in the year. So this 2 comes in, so there's 2 nitrogens. Then that's going to multiply with a 3 to get 6 oxygens, okay? So we have 1 barium, so barium plus 2 times the number for nitrogen plus 6 times the number for oxygen. So double check that you can go ahead and add those up. When you do, you're looking at about 261.35. And then grams per mole is always going to be our unit for molar mass. So we need to be able to use these. We'll use them throughout the entire year. So make sure you kind of learn how to do this now. Make sure you know what number you're reading on the periodic table. You're reading the one on the bottom, not the one on the top. The mass number is the one we want, which is the one on the bottom. Atomic number is that one on the top.